Hey everybody, today we're going to do an introduction to Mathematica. Mathematica is kind of programming, it's high-level programming, which means it's very user-friendly, unlike Fortran or something dreadful. So just with a little bit of programming knowledge, what you essentially get is like the world's best calculator, because you can solve equations, you can solve matrix equations, you can make really pretty plots and pictures. It's very, very useful. And so I wanted to give you an introduction to this. Okay, so first thing, I've opened up Mathematica already and I want a new document, and the new document type that you're always going to go with is notebook. I literally pretty sure I've never used anything other than notebook. Okay. First thing we're going to talk about is types of cells. So we have programming cells where we are going to type our code, but we also have regular text cells, which is really good for like organizing your notebook, so that if somebody has to grade it, they know what you were doing. So first thing we're going to do is, like you can see here, this is a programming cell. So like if I wanted to do plus, maybe I'll do something that makes more sense, like 4 plus 5. That's a programming cell. It's very tiny. But if you hit something like Alt 1, now we've got regular text. So I'm going to write Introduction to Mathematica. And then as long as you're clicked into the cell, you can go through Alt 1, Alt 2, Alt 3, 4, 5, 6, 7. Those are already regular text cells. If you hit Alt 9, this is a programming cell. Alt 8, I don't really know what that does, but we'll stick to the normal ones. So I'm going to say Alt 4 is a pretty good size for titling your document. So like saying homework number 2 and then putting your name in it so I know who it belongs to. Very important things right there. And then maybe I want to tell you what we're going to talk about first. We're going to talk about defining constants. So I'm going to use Alt 5. Constants, and Alt 5 is tinier than Alt 4. If you didn't notice, we started at Alt 1 and then we went all the way to 7 and they just got tiny, 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 tiny. Okay, so then what we're going to do under constants is we're going to start actually doing some programming stuff. So in order to get from one cell to the next, I just push my down arrow, and I don't have to start the cell. If I just start writing, the cell opens up and it's always going to be a programming cell. Okay, so what I want to do first is I want to assign a number to a variable. I want to say that a equals 5. And so it's literally that easy. You say a equals 5. And then if we hit Shift Enter, that's one way to evaluate the cell. If you come over here and you click on the cell itself, right click, you can click Evaluate Cell like that. And then now we have A is equivalent to 5. Whenever Mathematica sees A now, it's going to see 5. And then maybe we don't want to see that. If you hit Shift Enter now, notice the difference. It didn't pop up with 5. So now I want to also define B. I'm going to say that B is equal to 9. Notice that B is blue, where A is black. That means B hasn't been assigned to anything yet. He's empty and ready to be used. So I'm going to hit a semicolon to suppress the output, Shift Enter, evaluate it. Notice B is now black. So now Mathematica says A equals 5, B is 9. Anytime I see A, B, use 5 and 9. And I'm going to use that information to add the numbers 5 and 9 together. So I've got a new variable C, and I'm saying that C is going to be equal to A plus B, because A is 5 and B is 9. And then if we enter, Shift Enter, we get 14. Yay, 5 plus 9 is definitely 14, so I'm happy. But notice I've got C in a different cell than I do A and B. This can cause problems. For instance, if I end up using a as something different later, so notice now Mathematica A thinks that a is -1. When I come back here, it still thinks a is now -1. Notice our answer changed. Mathematica doesn't read top to bottom. It reads by what was last run. So it is much safer. I'm going to delete this. Just click on it and you hit your delete on your keyboard. Then I'm going to move him to be with his friends. If you're going to define some constants, you should do it in the same place where you're going to use them. Otherwise, who knows what's going to happen. So now if I run this, a has most recently been told that it is 5, and so we're going to get the right number. Okay. Also, forgot to mention, I did not suppress the output on C, because if I did, I still wouldn't know what A plus B was. You usually want to suppress the output on all the things that you define, and then what you're looking for, you don't want to suppress the output on. Okay, so that's constants. C is not a function. The way you do functions is different. So we're going to do Alt 5. We're talking about functions now. And then maybe we want to hit enter a few times so that we can very clearly tell that we're somewhere else. Okay, so if we want to do a function, what you're going to do is f square bracket x underscore close square brackets. And then let's say that I want this function that I'm defining to be equal to x cubed. So if I want f of x equals x cubed, we're going to do colon, to come back, colon equals. We're not going to just do equals because we're defining a function. Here, before I said a is the same thing as 5. This is defining a function. This is different because I'll be able to do things like plug numbers in. Okay. So x cubed. Also know, or notice, that x is green. It's because x is a variable. Okay, so let's see, f of 5 would be 125. Let's check it. You'll notice that f is blue right now because f is an undefined function. I haven't run it yet. But if I do this, there we go. And then we still have the same a defined as before, so I could do like f of a. And there we go. Either way is a great way of plugging in 5 to this function. All right, maybe, oh, also notice that when I plugged stuff in, I didn't have an underscore. You only do the underscore when you are defining a function. Now let's say that we want to do something crazy. We want to see how x cubed is going to change if we do something like, we want a visual representation of how x cubed is changing if we multiply it by a constant. So like if I had a times x cubed and I wanted to make a 2 or 13 or -5, what's that going to do to the plot? Hopefully you know what it does to the plot, but let's have a picture of what it does. So the way that you would want do this is the command manipulate. You've probably seen these and this pop up in the lectures that I've already posted before, where I let you play with some things to give you some visuals. So what we want to do is we want to manipulate the plot x cubed. That means we need a plot of x cubed. So let's start off with plotting x cubed. So that's going to be, I'll go ahead and start a new cell. We'll do plot, and I'm going to plug in f of x, and then you put a comma. So you put the function that you want to plot, followed by a comma, and then you say, here's the variable that I'm using. This is the domain I want. So I'm doing -4 to 4 for no particular reason. And then make sure that these guys are the same. Make sure we're using square brackets. And then also notice that the brackets keep on lighting up, which is great for if maybe I put in an extra parenthesis or curly brace. We've got these guys are paired up, but then when I go over this curly brace, it doesn't light anybody up. So he doesn't have a friend. I have too many curly braces. There we go. Now everybody's matched up. So now if I run this, now we have a plot to play with. Okay, so now we're going to do manipulate. Now I want to know how to do manipulate, but maybe I don't remember how to do manipulate. There are two ways to look this up. You can go to help and go to Wolfram documentation, and then you can search whatever it is that you want to help on here. Or you can do what I do and just go to Google. Oh, it's already sitting here. Manipulate, Mathematica. Basically anything that you want to look up, followed by the word Mathematica. And chances are the very first link is going to be exactly what you want. So, introduction to manipulate. So we've got manipulate it is not finished loading the page. Please load. There we go. Where is the top? Okay, so something's wrong here. It's not telling me manipulate up here. It should give me like a syntax. I don't like this. So I'm gonna back out. Here we go. It wasn't the first result. Lied to you. I don't want introduction to manipulate. I'd rather just look at the manipulate documentation. There we go. This is what I was looking for. This gives you like the template for what manipulate should be. So I'm gonna bring back this guy. I'm like, I would like to manipulate something. I don't know what yet, but it's going to involve a comma and some curly braces. So I am now ready to start putting things in. If I go back to this page, I could look at an example. So for example, we have manipulate for this plot of sine where we multiplied x by a, and a is the thing that's changing. So if we hit play here, it'll actually show as a changes, that's how sine's going to change. So what we do in order to do that is if I go back up here, you need the expression that you want to manipulate. Here they did sine. You want all of this plot stuff. So notice they have their function that they plotted followed by the domain that was plotted just like we do. So let's go do that. So I'm going to go get this stuff and I'm going to say I want to manipulate, and then where I have expression, I want to manipulate my plot, please. And then it's followed by the parameter that we're manipulating, what range we want it to be in. So that was what umin, umax means. See, it generates a version of the expression with controls that let us manipulate the value of u. I want to manipulate something called a. So a is going to go from -10 to +10. Sure, I like it. But notice I don't have any a here for manipulating. It doesn't know what I want to do with a yet. I said I wanted to do a times x cubed, so here we go, a times x cubed. And then you'll notice that a isn't blue or black or anything, it's green, so that you know if I were to get rid of this, a is now black, it's going to use a equals 5 from before. If I hadn't defined a, so like if I did c, oh, I used c too. If you use d, it would be blue, but as soon as I put d in here, it's going to be green. And so it sees, we're doing this locally, is what it tells it. Okay. So if we hit Shift Enter, what do we get? It's going to take a moment. It's thinking. There we go. Here's our plot. So now you can see the axes changing, and so that means your plot must be changing, but that's really infuriating, isn't it? So I need to tell it that I want to change the plot range. So notice I put a comma, and I'm going to do something after that comma that's going to fix the range. I need to tell plot, only do this range, stop moving. So we're going to do plot range Mathematica, yes please. There we go, first one, plot range, bam. How do we do this, please? So not a whole lot is said right here. So I just scroll down to the example and I'm like, okay, so the way I'm gonna do this is I'm gonna do plot range arrow, and you do the arrow, doing plot range, and then minus sign, greater than sign. And then if I start typing, it turns into the arrow. You don't want to do automatic because it's already doing the automatic. Automatic just says do what you would have done before. By default, it's automatic. I want to control this. And so it looks like I could do, so this is graphics, it's different than plot. But I see here that they've done some curly brace stuff in order to control how wide and stuff it is. I don't need to do two sets because I already did the domain. I just want to do the y value. So I'm just going to go ahead and say, well, let's just test that out. Let's say I want to go from -10 to +10 with curly braces. Notice, I think I pointed this out, but just notice again, plot range is inside the plot function. It's not inside manipulate, it's inside plot. Manipulate just gives us power over D. So there we go, plot range, aha, 10 to -10. And as we change D, it's not changing. Excellent. So now you can see how it changes. Perfect. So there are a lot of functions that are defined in Mathematica. For instance, we're going to do Alt-7. Functions in Mathematica. For instance, you've got sum. That's going to be the same as like summations from Calc 2. You've got ABS, which is absolute value. You can do a table. You can do a for statement. You can do an if statement. Notice they're all capitalized. Notice they're all followed by squared braces. Mathematica cares. If you do lowercase, it's not going to do what you want it to do. Okay. And then you can look up the documentation on all of these, and it should be fairly well explained, and if nothing else, it'll give you an example, and then you can copy the example over and change things in the example and see how that changes things. Okay. I think that's going to do it for functions. Let's move on to matrices because we are in linear algebra after all. Let's do Alt-5 matrices. Okay. So let's say we want to solve AX equals B. Well, first thing we need to know is how do you write a matrix in Mathematica? And once again, I'm going to go and check out my very helpful Google documentation because I never remember matrix Mathematica. There we go. Because I primarily program using MATLAB and Python, and they do it different. And I don't use this one enough to remember. So how to create a matrix. Yes, please give me examples. Aha! Here we go. Here's a matrix. And then notice they've got something called matrix form. And so you can see when it's in the pretty form, 1, 2, 3, that is the first row. So you have to put your matrix inside of curly braces, and then row 1 will have its own curly braces, and row 2 is separated by a comma, and it gets its own curly braces. And all the entries are separated by commas. Okay. I don't want to write that out. I'm going to copy it. Control V. There we go. But I don't want it to be called mat. I want him to be called A. And then I know they did like the / matrix form, but I personally prefer matrix form to stick him inside like that. So I suppressed the output on A. Here, I'll actually show you what it looks like with no suppressed output. Okay, it looks exactly the same. It's not exactly easy for us to read. That's not what we're used to looking for. So matrix form A. There we go. Now it looks pretty. I like that. Okay, so that was a matrix. Now let's do a vector. Remember, we want column vectors, not row vectors. And so since in order to do a column row or column vector, you're essentially going to need each entry to be its own row. So let's do vector V is equal to, and then we'll do 3 in the first row, 1 in the second row, 4 is our third row. Okay. So then we need to let's try doing A times V. So A times V is done this way. You do a period, and then you hit Shift Enter, and you're like, oh yeah, I don't want to look at that. I can read that, but I don't want to. It's too hard. Matrix form, please be pretty. There you go, much better. Okay, so apparently when you do A times V, you're going to get 174165. Now let's go trickier. Let's solve AX equals B. Now that we know how to write A, we know how to write vectors, we're pretty well set. So we need an A and we need a B. Yes, I have defined them before, but that is fine as long as you just redefine them here. So I'm going to do my initial curly braces. My matrix has to be in curly braces. And then I'm going to do 3 rows like that. Okay, so first row that I want to do is going to be 1, 0, -1, 0, 1, 5. Oh, needs a comma. You'll notice that little grayed out X. If you put a space, Mathematica thinks that's multiplication. So it needs a comma. And then 2, 2, 9. And then you'll notice I put like spaces here, but they didn't put spaces up here between theirs. I just like spaces because it helps me see things better. You'll notice all the spaces that are like over here. And it's fine. Mathematica doesn't see them. It doesn't care. And then we'll do the B vector is 8, -2, 7. You may or may not realize that this is example 2 from lecture 1, when I solved a system of equations using Gaussian elimination for the first time. This is the coefficient matrix A, and that was indeed the right-hand side B. So the command to solve this is going to be linear solve, and then you're going to do A, comma B. Yes, the order matters. Do not do B, comma A. And then if we hit Shift Enter, we're like, oh, that's ugly. Matrix form. Actually, let's try. So I'm a creature of habit. I don't like doing new things. So it's got this like / matrix form. Let's go ahead and try that. Oh my goodness, it worked. That's so cool. All right. So we have indeed verified when we have this coefficient matrix A, and the right-hand side would be B. This is how or this would be the solution vector x, which means I solved it correctly in lecture. Yay me. Okay. I think that's most of what you need to know about matrices. Not a whole lot to know about them yet. Let's see, Alt 5, other things to know. Good things to know. There we go. And then I'm going to do Alt 7 so I can type some things in for you. So any good programmer knows that you're going to run into syntax errors. It's going to happen. Something's not going to run. And when that happens, you're going to get a red angry cell over here. And it'll have like an orange plus sign box to click. And if you click on it, it'll tell you what's wrong. So then, so syntax error, click plus, click this guy by the side of the red cell. Maybe you want to evaluate your whole notebook. So moving on, if you like close your notebook and then you open it again later, you don't necessarily want to run through and do shift enter, shift enter, shift enter in every single cell. And what you can do is you can go up to evaluation and you can evaluate the entire notebook, which is going to evaluate it top to bottom. Evaluate entire notebook from top to bottom. You click evaluation and then you go to evaluate notebook. Another helpful thing is maybe Mathematica gets stuck doing a calculation and it is taking forever, or maybe stuck in an infinite loop. Whoops. You can again go to the evaluation tab and you can tell it to stop. So you can quit evaluation. You go to evaluation again and click abort evaluation. And then last of all, let's say I open up a new notebook. I've already defined things like A, B, C. And if I were to put C in over here, notice it's still 14. It remembers that ever so helpfully. That's not helpful. It really angers me, actually. So maybe you want to make sure, super sure, that you don't accidentally use something that's been defined, and when you think you have a variable, you actually have a constant. You can clear variables by doing clear, start parentheses, global, and then you know the like single backwards quote that goes with the squiggle sign? You're using that quote, not the normal quote. And then star, end quotes, square bracket. So if you run that command up at the top, that should clear all your variables so that you don't end up with some a equals 5 when you think you have a is clean. Okay, I think that basically summarizes in the basics of Mathematica. We now know how to define constants, we know how to do functions, we know how to do matrices, we know how to solve matrices. There are also ways to like solve functions. Like if you wanted to do x cubed equals 0, which wouldn't be very interesting, but you could solve that here in Mathematica. It is a crazy awesome calculator with very pretty plots. We didn't even touch on a lot of things. I really like visualizations. I make lots of pretty pictures in Mathematica, actually. You can do things like add labels to your axes. You could label your graph. You could change the color of the line. You can put multiple lines on one graph. You can do a lot of stuff here. But I think this is all we have time for right now. And just know that if you should ever want to do one of those things, just try typing it into Google and look at the examples they have, and you should be able to get a pretty good answer that way. Anyway, that's all I have for now. Bye.